calculate the distance between 2 points. The goal of this tutorial is to be able to answer questions like the one on the screen. Calculate the distance between the points 4, 6, and 1, 2. If you visit our website, you'll be able to try this problem, several others, and enjoy some other neat things like a free worksheet and an interactive program that calculates the distance while you move points around the screen. So, calculating the distance between 2 points is going to boil down to basically being the Pythagorean Theorem. And before we look at the formula itself, let's plot these 2 points and look at what we're trying to find. Let's plot the point 4, 6. 1, 2, 3, 4, 6. And let's also plot the point 1, 2. X is 1, y is 2. Right here. So we've got our point 1, 2, and 4, 6 on the screen. What we're trying to do is find how long this line segment is right here. Since it's a slanted line like this, there's no easy way to look at the graph and figure out exactly how long that line is. But let's draw a right triangle and see what that does for us. And here's how we're going to draw this triangle. We're just going to go straight down from 4, 6. Alright, not the straightest line in the world. And we're going to go this way, directly sideways from 1, 2. Since we're going directly down and directly sideways, we know that this is going to hit at a right angle here, and we've got a nice right triangle. And we're going to use that to our advantage to be able to figure out how long this distance is. So let's see how large, or what's the size of this side of the triangle? 1, 2, 3, 4. This leg is a side of 4. This is, if you count it up, this here is 3. And what we're trying to find is this distance d. So we've really got a right triangle here. All right, we know one leg is 4. We know one leg is 3. And we're trying to find the hypotenuse, or the distance here. So we can use the good old Pythagorean Theorem, which, if you remember, says this 3 squared plus 4 squared equals d squared. So let's use this method to calculate d. We know d squared equals 3 squared plus 4 squared. In other words, d squared equals 9 plus 16. D squared equals 25. So d is going to equal the square root of 25, or 5. Pretty straightforward, right? So one easy way to calculate the distance between 2 points is to draw this right triangle and just use the Pythagorean Theorem. And just so you know, you could have drawn the triangle this way. I mean, if you had gone up 4 here and 3 this way, you'd still get the same formula. You would end up with a triangle that looks like this. 4, 3. And notice this, it's the same formula here because d is still the hypotenuse. You still get d squared equals 4 squared plus 3 squared. So you can draw your triangle any way you want. Alright, so this works great whenever the points are sort of close together and you have graph paper handy. How can we find the distance between points that are, further apart, that are not so convenient to graph? Let's look at how we found 4, the side that goes up and down. 4 is really 6 minus 2, or y2 minus y1, right? So let's write it that way. 6 minus 2, right? We're just taking this 6, we're saying 6 minus 2. And 3 is really the 4 minus the 1. And notice we have a plus here, where we're adding them in our formula. We said that d squared equals 3 squared plus 4 squared. We know that this is going to be our 3 here. 4 minus 1 will be our 3. 6 minus 2 is going to be our 4. And we know that d squared, sorry, a little messy here, d squared equals all of that. Alright, so in the end, we were taking the square root of that number. D equals the square root of 4 minus 1 squared plus 6 minus 2 squared. And this is going to be our general formula for the distance formula. The distance formula is going to be a general version of this. It's going to say the distance d equals the square root of x2 minus x1 squared, right? We squared the 3. We're going to square this. Plus y2 minus y1. Again, squared. Right? And this boiled down to d equals the square root of 3 squared plus 4 squared. Okay, so let's try one more problem to see if you understand it. We want to calculate the distance between the points in -1, 2, and 4, 14. And on the left here's our general formula. x2 minus x1 squared plus y2 minus y1 squared. Square root of all of that. Now, I included this graph here, but we're not going to use it because I just want to point out -1, 2, although that fits on the graph. 4, 14, it's just outside of this graph's dimension. So let's look at how we can just apply this general formula. We're going to say d equals, and we might as well say this is x1, y1, this is x2, y2, d equals the square root of x2 minus x1, 4 minus -1 squared, plus y2 minus y1 squared. This is a 1 here, by the way. Y2 is 14 minus 2 squared. What we're going to now do is do a little arithmetic. 4 minus -1 is going to be 5. Right, this whole thing is squared plus 14 minus 2 is going to be 12 squared. So we're going to take the square root of 25 plus 144, or the square root of 169, which is 13. Right, so if you had actually plotted these points out, x equals -1, 2, and y is way up here. It's 1, 2, 3, 4, 14. Just so you understand what it would look like if we did the triangle method. It would be something like you got one side is 5, one side is 12 of our triangle, and we were trying to calculate this d squared equals 12 squared plus 5 squared. So once you practice this a few times, you just end up using the formula x2 minus x1 squared plus y2 minus y1 squared. But just remember, this is really just the Pythagorean Theorem. And since we're talking about a distance, we always need to use the positive. Here, like the square root of 169, we only want the positive 13. That's it. Again, if you want more practice with the distance formula, including a free worksheet, a neat interactive program that lets you move points around and dynamically calculates the distance, visit our website, mathwarehouse.com/DF for distance formula.